Hello, this is Mrs. Nearing, and we're going to be talking through how to balance chemical equations. So, we're going to look at some of these problems here and work through our steps. So, step one when we're balancing chemical equations is going to be to make a T-chart, and I'm going to count up the atoms on both sides. So, I've got iron and I've got chloride. And initially on the left, I've got one iron. So, if you don't see anything written here, you assume it's a 1. So it's kind of like there's a 1 here and there's a 1 here, basically. So we've got like one iron over there. And then I've got two chlorines, because that's 2 right there. And I've got one iron and I've got 3 chlorines over here. So next step is I want to pick one element that I want to balance. So my irons are already balanced, so let's pick the chlorines. And you want to look for lowest common multiples, like the lowest number 2 and 3 can have in common, and that's 6. So let's make it so we have 6 chlorines on each side. So in order to do that, I would put a 3 right here. That would give me 6. So what you do is you multiply this number by the, that's called the coefficient. You multiply the coefficient, let me label this over here. This is called the coefficient. And then this number right here is the subscript. And the coefficient times the subscript tells you how many of that atom you have. So 3 times 2 gives me 6 chlorine atoms. So I want 6 over here, so I want this to be a 2. So now I've got 2 times 3, I've got 6 chlorine atoms. And then for iron, it's 2 times 1. So if we don't see a number, it's like there's a 1 there. So 2 times 1 is equal to 2. So now I need 2 irons. So over here on this side, I'm going to put a 2 here. 2 times 1. Now I've got 2 irons. So yay, now I'm balanced. I've got 2 irons on each side, 2 chlorines on each side. Alright, let's look at this next problem. So I'm going to set up my T-chart. Copper, silver, and then here we're going to introduce trick number 1. Trick number 1 is if you have a polyatomic like nitrate, carbonate, sulfate that shows up on both sides of the equation, you can treat it as just one thing. So instead of breaking out the N's and the O's, I'm just going to count how many NO3s I have. And that's going to make my counting a lot easier. So over on the left, I've got 1 copper, 1 silver, 1 nitrate. On the right, I've got 1 copper, 1 silver, and I've got 2 nitrates. This subscript, when you see with the parentheses, applies to everything inside the parentheses. So I've got 2 NO3s. So I'm going to pick something to balance. The only thing that's not balanced is my nitrate. So I'm going to put a 2 over here. 2 times 1, now I've got 2 silvers. And then 2 times NO3, now I've got 2 NO3s. Okay, so now my silvers are out of whack, so I'm going to put a 2 over here. That gives me 2 silvers, and I am balanced. Okay, let's look at this one, number 3. I've got lead, I've got nitrate, I've got aluminum, I've got chloride on both sides. So I'm going to go through and I'm going to count. I've got 1 lead, I've got 2 nitrates, 1 aluminum, 3 chlorides. I've got 1 lead, 3 nitrates, and that applies to whatever's inside the parentheses. I've got 1 aluminum, and I've got 2 chlorides. So I'm going to pick something to balance. Let's start with the chlorines. I've got a 3 and a 2, so the lowest common multiple of that is 6. So let's make it so I've got 6 chlorines. I can do that by putting a 2 right here. 2 times 3 gives me 6. 2 aluminums, that makes this a 2. And then I want to balance out my chlorines on this side, so let's put a 3 right here. 3 times 2 gives me 6 chlorines, and then I've got 3 leads. So my chlorines are balanced, but nothing else is, so let's try balancing out my leads maybe. So let's put a 3 over here, that'll give me 3 leads. It'll also give me 3 times 2, 6 nitrates. So let's try and balance out my nitrates. In order to get 6 nitrates, I'm going to put a 2 here, so 2 times 3 gives me 6 nitrates, 2 aluminums, and now I am balanced. Alright, so let's try this next problem. I've got iron, I've got oxygen, I've got carbon. On the left, I've got 2 irons, 3 oxygen, 1 carbon. On the right, I've got 1 iron, 2 oxygens, and 1 carbon. So I'm going to pick something to balance. Let's go with the O's first, because I got the 3 and the 2. Let's give that a shot. So, again, 3 and 2, lowest common multiple is 6. So let's make it so we've got 6 oxygens on each side. So 2 times 3, I've got 6 oxygens. 2 times 2, I've got 4 irons. So let's balance out the O's on this side. Put a 3 here. 3 times 2 is 6 oxygens, and 3 times 1 is 3 carbons. Alright, now let's balance out my irons. So I need to have 4 irons over here. So if I make that a 4, 4 times 1, I've got 4 irons. And then I need 3 carbons, so I make this a 3. And now everything is balanced. Okay, let's take a look at problem number 5. Again, we've got a bunch of polyatomic ions. We've got magnesium, we've got nitrate, and we've got, so nitrate and PO4 are my polyatomic ions. That's going to make this problem a lot easier if I can just treat them as one unit and not have to count up all those oxygens. So I've got 1 magnesium on the left, 3 on the right to begin with. I've got 2 nitrates and 1 nitrate, 3 potassiums, 1 potassium, 1 phosphate, 2 phosphates. So I'm going to pick something to balance. What should we do first? Let's maybe do the magnesium first. So let's put a 3 over here. So 3 times 1, I've got 3 magnesiums, and then 3 times 2, I've got 6 nitrates. So now let's maybe balance out our nitrates. I need 6 nitrates over here, so I'm going to put a 6. That'll give me 6 potassiums and 6 nitrates. And then I need to balance out my potassiums, because I got 6 on this side, only 3 over here. So in order to get 6 potassiums, I want to make that be a 2. So 2 times 3 gives me 6 potassiums. Then I've also got 2 phosphates, and I am all balanced. Alright, so let's try this one. This one looks a little bit like a combustion reaction. It's something plus oxygen makes water and something else. So these ones can be trickier ones to do. So HSO, HSO. I start with 2 and 1 and 2. And this is 2 and 1 and 3. So you might notice that the H, usually it's good to save the O for last because it shows up in more than one spot. But in this case, the H's and the S's are already balanced, so that might make this problem a little bit tricky. One thing I noticed, though, is notice on the left, the O has a 2 by it, and over on the right, my H2O just has 1 oxygen in it, so it's going to be an odd number. So I'm going to be destined to have an odd number on the right, which could be an issue. So actually, the first thing I'm going to do is I'm actually going to put a 2 in front of my water, just to make it so I have an even number of oxygens on the right. Remember, balancing is kind of like a guess and check. If you don't do this first, that's fine. But this is kind of an instinct. I'm like, I think I need to have an even number of oxygens on the right, so make that a 2. So now I've got 2 times 2, I've got 4 hydrogens, and I've got, now I have 2 plus 2, I've got 4 oxygens on the right. Okay. So now let's go back and balance out my, let's look at my hydrogens next. So I got to put a 2 here to balance out my hydrogens. That gives me a 4, but that gives this a 2. So now my sulfurs are messed up. Okay. But I'm going to stick with it. I'm going to have faith here. Let's try and make my sulfurs okay. So I'm going to put a 2 over here. That's going to give me 2 sulfurs. It's also going to redo my oxygen count. So now I've got 2 oxygens from the water, and I've got 2 times 2, I've got 4 oxygens. So I've got 6 oxygens over here on the right. But my H's and my S's are balanced now. So now I just need to balance out my oxygens. I want 6 on this side. So the way to get 6 is to go 3 times 2 equals 6. So I stuck with it, and I am balanced. So I'm going to pause this video here. I'll make another one later if you want more practice.